Hello, Math Study students, and welcome to your online lesson. Today we'll be continuing our unit on functions and specifically talking about domain and range. Our goal is to be able to efficiently identify domain and range of a function. So what is domain? Domain is introduced to students probably pretty early on, maybe even middle school mathematics, or certainly by the time we get to freshman algebra. Yet, as I teach upper level students, they often forget what it is. If you think about the word domain and even range in the real world, we're usually talking about a large group or area of things. Like a king might have a domain, or a region that it rules over, and a range of things. We could have a wide range, or we could have a range like a farmer has a range of land or something like that. Well, both of these things in the real world are referring to large groups of things or regions. And that's what they are in math as well, but each one is a specific region. And the domain is the set of all inputs, or all the possible values that we can plug into a function. And those are usually our x values. The range is all of the outputs, often our y values, or all the things we get out of our function, or an f of x value. And a way to remember it is input and output. They're alphabetical. I comes before O. Domain and range are alphabetical. So domain comes first. That's the in. Range comes second. That's the out, just like inputs and outputs. So again, domain is X, range is Y, inputs and outputs. A little bit of review notation before we get on to our examples for today. If a graph contains an open circle, and we see that right here, that point is not included as part of the actual graph. It's essentially skipping over that point. And then if a graph contains a closed circle, that means we do include that point. It's equal to that, it contains it. And then lastly, we use these all the time, but just a quick review. If we have a graph that ends with an arrow head, that is indicating that the graph is continuing on indefinitely or forever in that same direction. Or if we have a graph where there's a pattern, such as like a sine wave graph that would look something like this, again, I could put an arrowhead to indicate that it's going to continue on doing that same pattern thereafter. All right. So we're going to see those appear a little bit on our next example, and I will talk about how to actually express domain and range. So state the domain and range for each of the following functions. So what we have to do is we have to list what are the possible x values. And a graph is made of infinitely many points. So I can't actually list all the numbers, so I essentially want to write a set. The way we write a set, as we saw in the last slide or the last video lesson, was that we take this little gull wing called a brace, and I start off my set that way. Domain, what is domain? Well, it's x's. So we just write x, and then we write a vertical line. Not the number 1, not an L, but a vertical line, which means given or such that. So x is defined as x is such that, x is given. And now what we're going to do is we're going to list our values. And x is left to right. So as I look at this graph, way over here on the left side of the graph, what is happening to our actual graph? Well, it has an arrowhead, which means that it is continuing on and on and on in this direction, which is both going up and to the left. Well, how far to the left? Forever. So what's the lowest value? Well, right here, I have my origin, which has an x value of 0. But we're going to the left of that. We might have like here, have a point with an x value of -1, -2, -3, -4, -5, negative, on and on and on. So when does it stop? It doesn't. So the lowest value would be like infinity, but it's negative infinity. That's as low as it goes. And then we have the graph continuing on, goes up, goes down, but again, we're only concerned about the x values. And here we have a little point, but it's a closed circle, and so it includes that point. And then we have another closed point right here at the end, so that's also included, but that's where it stops. It doesn't go past this value. And we know the x value there, it's 8. So I'm at the far left, I have negative infinity. On the far right, I have 8. And those are my x values. Now, I know nothing is less than negative infinity. I'm always going to be using some sort of less than sign. So I have negative infinity is less than my x. Can we ever reach negative infinity? The answer is no. Can we ever reach this 8? Well, it's a closed circle. So we actually get there. So x is in between negative infinity and 8, but it can equal 8. It can't equal negative infinity. And then I close off my set using my braces again. So what did I do here? I listed the lowest possible value. I listed the highest possible value. I put my x, which is what domain is, in between it. And then I used some version of a less than sign. If it couldn't equal it, I used just a regular less than sign. And if it could equal it, I used a less than or equal to. And we're going to do the exact same thing, but now we're going to do it for range. So range, I start off, again, making set notation. So I put a brace down. Now I have a y. Y is defined as, y is given as, y such that. And now I'm going to list my lowest y value. Well, y's go up and down. So I'm not concerned about the left and right. So I want to start with the lowest possible value. And that's this point right here again. And the lowest value we have here, it's not 8 this time because that was our x, it's the y. And so our lowest y is 2. Now, as we look where our graph is going, as we go higher and higher, my graph is going up. That's the highest point on my graph, and it's an arrow indicating it's continuing on. And this graph is going up and up forever. So I never stop, which means my highest value is infinity. And then I'm putting a y in between those. I'm going to use some sort of less than symbol. Can the y actually ever equal the negative 2? Well, again, we had a closed circle here, so it can. So I'm putting less than or equal to. Can you ever reach infinity? No, there's always a higher number, so we don't use an equal sign for infinity. And then we close off our braces. And so our x is in between negative infinity and 8. It can equal 8. It can equal negative infinity. And our y is between negative 2 and infinity. We can equal negative 2, but we can't equal infinity. And that's our domain and our range. Let's repeat this now again for our other graph. So this is a parabola. We've seen it before. This is indicating a closed circle, which is our vertex, our lowest point. And we have 2, negative 1 at that lowest point. Now, again, for domain, I'm putting an x after my brace, my vertical line, which means I'm defining it, x such that. And now I'm going to have my lowest value. Well, x goes from left to right. And we can see here the graph is continuing on forever to the left. And so there's no stopping value on the left. So I would put down negative infinity on the left. And then as my graph continues to the right here, it's going to get higher, but I'm not worried about how high it gets for domain. I'm just worried about how far to the right it goes. And there's no indication it will ever stop moving to the right. So it goes on forever to the right. I put infinity there. I put an x in between. I can't reach infinity. I can't reach negative infinity. So I do not put any equal signs there, just less thans. And then I close off my braces. For my range, again, I open up my set notation with a brace. I put my y down such that now y is up and down. Let's start with our lowest possible value. Well, that's happening right here. Again, it's a y value, and that would be this negative 1. So my graph never goes below negative 1. It does actually go to negative 1. And then in both directions, it's going up and up and up. No indication of stopping, so my highest value would be infinity. I put my y in between. Now, did it ever actually hit the negative 1? And the answer is yes. That was our vertex. It included that on the graph, so I'd put a less than or equal to. And then for my highest value, it's infinity. You can't ever reach infinity, so I would not be equal to that. And voila, there is my domain and range for the second one. All right, moving on to another example with graphs. So on this one, I've got these dotted lines, and these dotted lines represent something known as asymptotes. Asymptotes are points on a graph or places on a graph that we cannot reach. And they kind of give us an equation. So they have a horizontal line or a horizontal asymptote right here, which they're saying is y equals negative 1. And then we have a vertical one, which I'll highlight in green here, x equals 2. And I cannot reach those values. So we're going to do our domain and range again, starting with domain, x defined as or such that or given. And we can see here that over on the left, this graph is continuing on forever. So negative infinity is where we are starting. And then it continues on, going to the right, And then it has a break at that asymptote, and it goes up to 2. But it doesn't get to 2. It gets close to it, closer and closer, but it never quite hits it. And so I would not actually go to 2. So I'm going to have x is less than 2, and x is greater than negative infinity. And then I can put a comma and pick up where I left off. And now my graph is going to continue on to the right here. But again, it starts at 2, continues on for infinity, can't ever reach infinity, it doesn't reach the 2, and then I can close off my braces. So there's a little jump here, and that's what this comma is indicating. So my x is any value between negative infinity and 2. It does not include 2, and then from 2 on to infinity, I continue on, and that is my domain. Try to give myself just a little more room here for my y's. And so I'm going to write y given. And so now we're looking up and down. And so down here we can see that my graph continues on forever below. So we're going to start off with negative infinity. And then it starts coming up here. And it stops at this horizontal asymptote, which is happening right here. This y equals negative 1. So I continue on up until negative 1. Put my y in between it. I never hit the negative 1. I never hit negative infinity. I can put a comma. And now I'm going to do the exact same thing moving upward. And so I had this break right here at negative 1, right here. And then from that point on, my graph continues up forever. So I had negative 1 going up to infinity. Y is in between. It never hits infinity. It never hits negative 1. For my last example, I am given a function, but I am not given the graph. So I need to see this graph. I can tell what type of graph it's going to be already because it has an x squared, so it's likely a quadratic, and it's going to be a parabola. But in order to see this graph, I need to graph it. And I think the easiest way for me to do that would be to use my TI calculator. So I'm going to grab that now. So the first thing we'd want to do on our graphing calculators is go to y equals, and we're going to type our function in. Our f of x is essentially going to be replaced with our y. And so I'm using y sub 1 is equal to, and then I'll just type the right-hand side of the equation or function as written, 1 minus, and then we've got our x squared plus 4x. Right, and from here I'm going to go to the graph key. And I can go to more of a traditional window, though this fits pretty well. If I go to zoom 6, we can get that 10 in every direction window. And I can see essentially what's happening. As expected, it's a quadratic, so we have a parabola. Since our x squared term was negative, it's facing downward. And I'm going to attempt to now write our domain and range. So for domain, again, we're defining our x. X is given as, and now we're going to list our lowest x value, which is the furthest to the left. Well, again, as this graph is continuing downward, it's also going to the left, and there's no indication that it's stopping. So I would have negative infinity. And then as the graph goes to the right, again, it continues on forever. So I would have positive infinity. In between there, I put my x. I'm separating those with some sort of less than sign. Since I can never hit negative infinity, I'm using less than, no equal to, and the same thing for positive infinity. And then I'm closing that off. We're going to do the same thing now for our range, which is our y. So y is such that. And we can see here, again, the graph is going down in both directions forever, so it goes way, way down. So that would be negative infinity as my lowest possible value. But it doesn't go up forever. In fact, it goes up to only this point right here. Now, how could I figure out exactly where that's going? Now, we might be able to just look at the graph and say, okay, it looks like maybe it's about 5 or something like that. But again, we can always just go to second and trace. We want to find our maximum in this case, which would be our vertex. Left bound, hit enter. I'm going to go to the right, hit enter, make my guess, and I can see that in fact my y is, or my maximum has a y value of 5. So I'm going to go up to 5 as my max, a y. Now, do I ever reach negative infinity? No, so I'm using a regular less than sign. But do I ever actually get to 5? The answer is yes, so I'm going to use a less than or equal to sign, close off my set, and voila, I have found my domain. I'm sorry, my range. All right, and that is our lesson for today. Till next time.